Now, let's try to solve this using Excel. So, andito na yung mga data na ginamit natin kanina sa example. So, after inputting the data, click the Data tab, then Data Analysis. For the data analysis, we have here the ANOVA 2-factor with replication and ANOVA 2-factor without replication. So we're gonna use ANOVA 2-factor with replication because we have more than one observations for each combination of our variables here. Then click OK. In input range, just select all the data or values we have. Next is rows per sample. So we can see here that there are 3 rows for boys and 3 rows for girls. So our rows per sample is equal to 3 and our alpha level is equal to 0.05. Then output range. Just select a cell where you want to put the output for this example. Then click OK. We can see that in summary data, for invoice group, it gives us the count, the sum, the average, and the variance of the boys' scores in 3 ages. Same with girls, we have here the count, the sum, and average, and variance of the scores of the girls in different ages. So the most important table here is the ANOVA table. It gives us the source of variation, sum of square, number of degrees of freedom, mean square, F-score, p-value, and critical value for F distribution. Now let's look at the sample rule, or the first factor. Our F value is equal to 5.65, while the F critical is equal to 4.75. And we can see that the F value is greater than the critical value. So our decision here is to reject the null hypothesis. Next is the column row. Here. The F value is equal to 8.21 and the F critical value is 3.88. And we can also see that the F value is greater than the critical value. So the decision here is to reject the null hypothesis. And for the interaction effect, F value is equal to 0.62 and F critical is equal to 3.89. Hence, P value is less than the critical value. F value is less than the critical value. So the decision here is to not reject the null hypothesis. Next, let's look at the P value. Our alpha level is equal to 0.05. First factor is less than alpha because 0.3 is less than 0.05. So the p-value for the first factor is less than the alpha. So the decision is to reject the null hypothesis. Same with columns because the p-value here is 0.005 less than the alpha. Lastly, for the interaction, we can reject the null hypothesis because the p-value 0.55 is greater than the alpha. Now let's interpret it using Selmin's plot. Go to the Insert tab, select lines with markers, then select Data. Under Select Data Source, click Add, and select the series name. For this example, I'm going to use the boys as the first series name. And the series value, so we're going to highlight the average scores of the boys of different ages. Then click OK. Same with the second second level of first factor age, the girls. Then the series value is equal to the average test scores of the girls of different ages. For the horizontal category, click Edit to input a label to the x-axis. Then, highlight the names of the second factor. Our second factor is the age. Then, click OK. And finally, click OK. Then, click plus sign to add a legend. Now, we can see which color is for boys and which color is for girls. Blue lines is the score of the boys and the girls is the orange line. We can see that the graph is not exactly parallel but nearly parallel, and the lines do not intersect with each other. From this, we can see that there is no interaction for the two factors. We can also see that there is a difference in the means of the student's score with respect to age and gender. The girl's score is higher than the boy's score. And we can see that as the age increases, so that their score as well. And now we can say that the age and gender group affect the student's test score in arithmetic tests. But the interaction does not exist. So that would be all. Thank you for listening.